Hello, ladies and gentlemen. Anyone know what is numerical simulation? In my topic, numerical simulation is basically a computational mathematical calculation to model a product. In reality, it's very difficult to imagine how the gas particles flow in an object. Hence, I will introduce the application of computational fluid dynamics (CFD) in this presentation to visualize the flow field of gas in retrofitted multi-cyclone separator. So, what is particulate matter? It can be divided into ultra fine particle PM1, fine particle PM2.5, and coarse particle PM10, or even larger. According to the research, cyclone separator able to remove coarse particle up to 90%, and is always merely used as pre-cleaner. In this study, I will focus on the optimization of removal efficiency of PM2.5 to upgrade it to the primary air pollution control system. It's very crucial to have air pollution control device as PM can cause serious environmental problems and health problems. There are many other air pollution control devices, but why we want to choose cyclone separator in this study? This is because it has simple design, low capital and maintenance cost, and able to withstand high temperature and pressure. I believe that most people heard about single cyclone and multi-cyclone separator, but do you know what is the retrofitted multi-cyclone separator? Retrofitted multi-cyclone (RMC) is a type of upgraded multi-cyclone with additional suction strip on the side of the dust hopper. This is the most unique part of RMC as its suction strip has the tendency to extract the fine particles and help to produce cleaner air. It's also called gas-solid separator, which apply the principle of centrifugal force where the gas flow in a spiral motion. Now, I would like to explain the purpose statement of this study. If the cyclone fluid is too high, it will lead to high pressure drop and high cost. If it is too low, it's very difficult for particles to reach the dust collector. And also, if the suction fluid is too high, it's very energy consuming. And if it is too low, the fine particles are hardly to be extracted. Hence, it's very important to determine an optimum flow rate in order to have a higher efficiency of retrofitted multi-cyclone separator. There are total 4 objectives in my study. The first objective is to predict the performance of RMC using different cyclone and suction flow rate. Next is to visualize the gas flow pattern using computational fluid dynamics (CFD). The third objective is to understand and observe the particulate movement. And finally is the most important part, which is scaling up the retrofitted multi-cyclone to industry scale. This is the scope for Objective 1. Performance of the retrofitted multi-cyclone (RMC) can be related to the overall collection efficiency, pressure drop, cut size diameter, and particulate emission, whereas the operating variables are cyclone flow rate, suction flow rate, inlet mass loading, and particulate size. This is the scope for Objective 2, 3, and 4. Pressure and velocity control of gas will be visualized through the application of CFD. Red color region represents the gas moved with high velocity or pressure, while blue color region represents the gas moved with low velocity or pressure. Interestingly, not only gas flow pattern, particulate movement also can be observed through CFD. The original retrofitted multi-cyclone with 4 small identical cyclones will be scaling up to 100 cyclones. Application of CFD is a solution of the problem statement. CFD is a powerful tool to simulate and verify the performance of RMC before come to costly prototype. K-echelon turbulence model is the most suitable model of CFD as it took lesser time to complete the modeling and provide accurate result as compared to other model. CFD is much faster and efficient to obtain the results than the experiment. In conclusion, for field simulation of RMC will be conducted using CFD. Theoretical experiment and CFD result of RMC will be compared in terms of collection efficiency of PM1, PM2.5, and PM10. I hope that my findings will be the basis for industry scale in the future. Thank you for your attention.